Okay, yeah, my name is Cain. I'll turn on my video for a moment. Tom is going to do the first portion of the presentation. So we'll be talking about two features that we've added for the upcoming version 2.8 of DAOS. And those are self-healing controls and interactive rebuild control. So we'll start with the first section here with Tom discussing self-heal properties at the system and pool level, and then I'll present the interactive rebuild control feature that we've added, and then do a short pre-recorded demo of that. So why don't we hand it over to Tom at this point, and I'm going to turn off my video while we do that.
Thanks, Ken. First of all, can everyone hear me? How's the audio?
Sound good.
Yes.
Okay, so I'm going to discuss self-heal on the DAOS system. So this is a component of auto recovery, and it's something that we've been working on over the last few months. So why is self-healing important in DAOS? So we'll talk about that quickly. So when in DAOS, when we have component failure, whether it's on a drive or another hardware component of the system, we automatically trigger rebuild, and that restores redundancy on a pool. Now, this is generally a good thing, but it's not always desirable in all cases. So sometimes we would like to have a policy or policies that give us more control over auto recovery. So that's not always triggered, and we have some user control over it. This kind of coordination will enable us to improve resource utilization on the system. So control when rebuild happens and exclusions happen, and have some way to control those self-healing responses. And next one, please, Ken. Thank you. So here's some self-heal policy syntax that we've introduced. So these are system level properties, so they apply across the whole of a DAOS system. And you can get the self-heal property by running the top command. So the system get prop self-heal, and that will return you a value of the property. And in this case, we have 3 flag sets. That's exclude, and pool rebuild. The first one, exclude, will basically enable system exclusions. So the rank can be excluded or excluded automatically from the system. And then pool exclude and pool rebuild regard the pool activities. So automated exclusion on a pool and automated rebuild on a pool. So the default value is all of them set so that all the self-heal capabilities are enabled by default. Set prop heal, set prop self-heal will enable us to set the property. And in this case, we're setting to exclude pool exclude, which will omit the pool rebuild flag and disable auto pool rebuilds across the system. So this system level property is to be used in conjunction with pool level properties or pool level policies. And so we have more granular control because we can set things individually on each pool, and we can get a pool level property by doing pool get prop P1 self-heal, which will give us the self-heal property value for the pool P1. And in this case, the value is set to exclude rebuild, which means that both exclusion and auto rebuild are enabled on that given pool. If we want to clear all the flags for a given property, self-heal property, we can set the assignment to none. Thanks, Ken. Next slide, please. So key points. We've got distinct rank memberships. That's an important concept. We've got a system level membership for all the ranks, and then we've got pool level memberships for all the ranks, and that's per pool. So a rank can be part of the system, but not part of any pools, for example, or a rank can be part of the system, part of one pool, but not part of another pool. And obviously the rank in each of the memberships can have different states. So the system level policy was introduced in DAOS 2.8. And in previous versions, we've had pool level policies available, but the system level policy enables us kind of greater control in large-scale rollouts and scalable, and it's a scalable kind of system. The one good thing about the system level policies is we don't need any engines or pool services running. It's kind of true. We may need one or two, but you can basically set the system level policy before you roll out all of your deployment, and that's a useful thing. The DMG pool query command gives us information about the pool, and it includes policy settings that will affect the capabilities on the pool. And we'll see some of that later in the example. Now, DMG system self-heal eval command is used to trigger the action. So it's the cascading actions that happen as a result of changing the system level policies. So when you change the system level policies, things don't initially kick in. They kick in when you're ready, when you trigger using that command. All this is part of an evolution in DAOS towards predictable automation and better experience for its users. Next slide, please, Ken. Okay, so the system level self-heal example. So we're going to go into a kind of real world example of where the system level policies could help. And specifically, we're going to show how control over rebuild will eliminate some unnecessary activity in the case of rebuild. I'm going to carry on until the end, Michael, and then take questions at the end if that's okay. So in this case, we'll just have a single DAOS system with one pool, 8 ranks and default properties. And we're going to initially set the system property to exclude pool exclude, which omits the pool rebuild flag and disables automatic rebuild on pools across the system. We'll then perform a full system stop and subsequently start all but 2 ranks. And this is to basically imitate the situation where we do a system restart, but 2 of the ranks on a given storage server don't come up again for some reason. And therefore the pool will remain in idle rebuild state because we've disabled the system level flag, but ranks will be excluded from the system and pools as expected by the system property value. Then we will set the property back to its default value, including pool rebuild, which will enable the pool to be rebuilt once the eval command triggers and it is issued. Thanks, Ken. So step 1, we're going to set the system property as explained with the set prop command. We'll then get the property value for the pool level policy, which we use the get prop p1 self-heal command. We can see that the value is exclude rebuild. So from a pool level policy perspective, we've enabled both those capabilities. And when we do a pool query P1, we get all the standard query information, but we can see that the rebuild's been disabled on the pool due to a system policy setting. Okay, thanks, Ken. So next step, we're going to perform a full system stop and then start all but 2 ranks to imitate their failures. It should be noted that we're doing 2 ranks on a single storage node, so we're retaining RF for the pool, so that when those 2 ranks fail, we can still carry on accessing the pool, and clients should be able to too. But we will be operating in degraded state. So we do a system stop for the whole system, then start the remaining 6 ranks that are not failed, and then we can see from the pool query output that we have disabled rank 6, 7, but rebuild has not been triggered, so we have idle. We list it as done, so rebuild is not happening because we've set the system level property appropriately, and that we now are operating in a degraded data redundancy mode because we've lost those 2 ranks. And next slide, please, Ken. So we have a choice here. The administrator has a choice because we're using the system level properties. We can either restore data redundancy straight away with either including or excluding the failed ranks. So if we have failures that are easier to repair, then we can fix them quickly, rejoin the engines which pick up the disabled ranks, and then we can use pool reintegrate to reintegrate them back into the pool, or we can use the eval command after updating the property, and then bring the pool back up with the remaining 6 ranks, but not the failed ones. So in this case, we'll do the latter. We set the property to include pool rebuild, which enables the automated rebuild on a pool. We run the self-heal eval command, which triggers the cascading actions, and therefore the pool rebuild happens. We do a pool query P1 where we see the standard information, including targets excluded, because we've lost some targets on the disabled ranks. And we can see that the rebuild is now busy. Data redundancy is degraded during the rebuild, and then it transitions to rebuild done when it's finished and redundancy has been recovered on the remaining non-disabled ranks. Yeah, that's the end of that part of the presentation. Thanks.
Okay, thanks, Tom. I'll go ahead to my section next. Let's see, I'll start my video. Okay, here we are. Okay, so next we'll talk about another feature related to rebuild in DAOS 2.8, interactive rebuild control. So we've added a few new commands to be able to, if you have a rebuild running, to be able to stop it manually using the DMG command. So at a per pool level, you can specify the pool label and issue a rebuild stop command for that specific pool's rebuild to be stopped. Okay. At a system level, if you want to apply this idea to all pools in the system, you can use the DMG system rebuild stop command just below it. And correspondingly, for the per pool and system level, we have rebuild start command. So this is not a pause resume interface. It's a full stop of the rebuild, and when you subsequently run the start command, it will start from the beginning. Furthermore, when you stop a rebuild, it applies to the currently running rebuild on a pool. It does not have any persistent effects beyond that one time. So it's a one-shot command. The effect of the stop will leave the pool targets in the state that they were that triggered the rebuild to begin with. So the targets remain in a rebuildable state. So if you subsequently run the rebuild start command, then that will go through a similar process as if you were restarting the system, or if you had a pool service leader switch. It would find the targets in that state suitable to be rebuilt, and it would launch just as it would in those other scenarios. Any other automatic fault reactions or administrator-initiated changes through the DMG command could potentially start another rebuild. Okay. While you're running a rebuild stop command, at the bottom of the slide here, the DMG pool query rebuild state that we were looking at a little bit with Tom's presentation will include some important hints about the operation. When the stop command is handled initially, the rebuild state will show stopping while it's still busy, and it will throw a specific error code, minus 2027, which in our code base corresponds to this error code called operation canceled. There will be a brief transition where the rebuild will show busy. And so it doesn't really indicate that it's stopping, but it's performing sort of an internal detail of rebuild, that when a rebuild fails, in this case, we're treating a stop as a failure of sorts, a failed reclaim process occurs. If you had a successful rebuild, the cleanup process is called reclaim. But finally, when the rebuild has been stopped, you'll see this final status here. So you'll still have the op canceled error indicator. The rebuild state will show idle, and then you'll see the word stopped in the output. Okay. So one slide on motivations for interactive rebuild. First, the first major point here is just the context, right? You could have a rebuild that's running, in which case you'll need to run a rebuild stop if you wish to do so, or maybe you've used the self-heal property that Tom was discussing before to prevent the rebuild from occurring to begin with. at this point, you could utilize the rebuild start command as part of your recovery procedure, right? And the main benefit here is that this is going to give us some options, right? We can, once we've either prevented a rebuild from happening or stopped one that had started, for whatever reason, now we have a choice. If the rebuild was for lost engines or targets, we could do nothing for a while and allow the pool to remain in the degraded data redundancy state, allow applications to keep using the pool in that state for some time. And then later we could decide, okay, now is the right moment to perform a rebuild start. If we wanted to allow that exclusion to sort of conclude, restoring the data redundancy with the surviving engines. Or we could choose instead to directly reintegrate the lost engines back into the pool if they can, again, be repaired relatively quickly and brought back online. And if you have a system with many pools, the interactive controls can allow you to choose to do this in a paced manner where you could select a few pools at a time to perform their rebuilds rather than have them all rebuilding simultaneously. Or if you prefer to do them all simultaneously, you could use the DMG system level command, DMG system rebuild start, and that would launch the rebuilds on any pools that have targets in that rebuildable state. Okay, so that's the main point on this slide. There are a couple of other cases that we have listed for potential motivations. So I'm going to move now to a pre-recorded demo, but this is a slide which will describe what I'm going to show. So we have a system with many pools. In this case, for demo purposes, I have a system with 2 pools constructed, P1 and P2. And the system will be configured with the self-heal property to omit the pool rebuild flag that Tom described. And then we will cause 2 engines on one server host to be lost. So this will result in those engines being excluded from the system membership, but also from pools P1 and P2 because they have storage targets on those 2 engines. But because the pool rebuild flag is not assigned, no rebuild will be triggered. And then we'll demonstrate an interactive recovery where at some moment in time where we decide we'd like to have those exclusions be dealt with by a rebuild process, we can run the pool rebuild start command on P1. And then we can do the same thing for P2. Like we could wait for P1 to finish and then start P2. And then I've got a bit of a contrived scenario here where the administrator might change his or her mind and decide, well, maybe I should stop this P2 rebuild and instead let's go to a direct reintegration. And it's contrived because I just want to be able to show the rebuild stop command and not just rebuild start. So let me get my pre-recorded videos just to kind of like walk through what that might look like. So I'll be doing most of my commands in the top window here. So we just get a picture of what the system looks like initially. So let me stop the video for a moment. So we have a system with 4 servers, 2 engines per server. So a total of 8, and the pools P1 and P2, as I described, they're currently in a ready state. They have 64 total targets, so there's 8 targets per engine, and none of them are disabled at the moment. And we can see that the self-heal policy on the system is including the default settings, which has all 3 flags enabled. Okay. Next, I'm doing some pool queries at the bottom of the screen. So I've got a Linux watch command to watch the DMG pool query of P1 on the left and P2 on the right. And then at the top, you can see that I've run the DMG system set prop to remove the pool rebuild flag. Okay, and then I've stopped the 2 engines 5 and 7. Let me stop the video just for a moment. To emulate the failure on one host. So we can see that ranks 5 and 7 on this system are part of the same server host name, number 241. So once I've kind of glossed through some of the normal delays that you might see when engines are killed. There is a bit of a multi-second delay where the swim protocol would observe that these engines have been lost and are not reachable by the other engines in the system. And once that occurs, then we can look at the pool query results and see that we have disabled ranks on both pools. There's no rebuild happening. We get that status message that Tom presented that rebuild is disabled due to the system level self-heal policy. And at this point, I could decide to use the rebuild start command to start rebuilding on pool P1. So now we can see that that's transitioned to busy. And I've done some video editing to make this process a little bit shorter. Now we can see that the rebuild is actually moving some data around. We will shortly see it go into a cleanup phase after a successful rebuild, where this object and record count will reset briefly. And then eventually this will show that we're done. Okay, so the pool P1 is done. Next, I'll run, I think this is going to run the pool rebuild start of P2. So now on the right where we're monitoring that, we can see now that the rebuild has transitioned to busy. And at some point here as the administrator, I'm going to change my mind and decide to stop this rebuild. So that command will be coming shortly. Okay, so stop P2. So now we'll see that the rebuild is in a stopping state. We're handling the command. And we have that special error code for op canceled. And now it's doing some fail reclaim cleanup. And then eventually it will show stopped. And at the top of the screen here, I'm just preparing for what I'll do next. But let's wait for pool P2 to show that its rebuild has been stopped. Okay, so there we are. And now we're going to restart those engines that were lost. This is presuming they can be brought back online quickly, that there's not some larger failure, like a hardware failure with the machines. And now we're going to, I'm just getting a picture of what I have. So I still have the system self-heal property set to pool rebuild disabled, but now I'm using a manual command to reintegrate the ranks 5 and 7 engines back into pool P2. So an important detail about self-heal policies is that they affect automatic failures and recoveries. They do not prevent a manual command like a DMG command from working. So in this case, we've instructed a reintegration rebuild on P2, and then that went forward over here, as we can see in the monitoring. And now I'm going to restore the system self-heal property to enable all 3 flags now. So if we have any subsequent automatic failures, then they would be reacted to and a rebuild would start. And I'm just doing a final picture of what the system looks like. So we can see here that we've left P1 in an excluded state, right, with the 2 engines being excluded, but the data redundancy is restored because we allowed the rebuild to conclude. And with P2, we did a full restoration of the engines and the data redundancy by doing a direct reintegration. Okay, so that's it for the demo and for our presentation.
Thanks, Ken.
Thank you for listening. And also, I didn't mention at the beginning, but Leeway, who's on the call as well, was an integral part of implementing these features and also helping to prepare for the presentation.
Quick question for Tom. So, or Ken, maybe you can also address this as well. Would using the self heal modification command to like disable pool rebuild, let's say you have a server that has a DIM error and someone wants to replace the DIM. So you could disable rebuild, shut down those servers or shut down that server. Those ranks would go offline, do the DIM replacement, bring it back online, and then re-enable pool rebuild to basically prevent rebuilding when it's not necessary.
So let's see, in this case,
Stop listening.
Yeah, I think in this case, it depends on whether or not that engine would have been excluded uh, with any connectivity loss before that property was set. Um,
Yeah, I'm assuming like let's say the system is running normally. Someone notices like a DIM is throwing errors, so maybe the system is still running. It's just there's a loss of a DIM. Um, so you want to service it. Can we disable sort of the self-healing attributes, do the maintenance item, and then restore the server and then re-enable? Or is that not the real intention of the feature?
I think the engine or the server, the engines on the server in this instance would be excluded. I guess if we set the self heal to none, right, no flags enabled, that may be a path to do this. I'm trying
Okay.
to think about whether that would work, right? So we would prevent exclusion from the system and prevent exclusion from the pool maps. And then if we bring the machine back up, I guess in theory, that could work. You may see applications if they're continuing to try to operate with that pool to experience timeouts as they try to interact with the targets that are currently offline. Uh, so that may be a path to do that. Tom or Leeway, or is there anything that I'm forgetting in this case?
I think that's mostly correct, Ken. I think if the system property is default at the time of the failure, then the rebuild will already happen when the exclusion occurs. So rebuild will be starting. So you wouldn't be able to prevent that initial rebuild, and then you would, I think, in any case, need another rebuild when you reintegrated that rank back into the pool. So you wouldn't be able to avoid a rebuild at that point. Leeway, do you have any further points?
Yeah, that's correct. In the future, once we have very fast mental reintegration, same allowing the exclusions would be the best approach here, because the application should be able to continue while the hardware is being repaired.
Okay.
Right.
Thanks.
So, yeah. So it sounds like we had three cases really to consider, right? There's the default self-heal, which Tom just described, and then what Tom had presented earlier, where we just omit the pool rebuild. That will result in the engines being excluded from the system and the pool map. So a rebuild would be required in order to restore data redundancy, or to reintegrate the engines after they've been brought back up. And then the third case that I was thinking about is setting it to none, right? And that would give you the possibility of doing a rebuild-less maintenance.
And that's exactly right. So for a planned system maintenance, for example, you might want to set it to none if you can basically tolerate the fact that some pools will be unavailable during the maintenance period, because that's the main point. Is that if you disable exclude and pool exclude on a system level, you're going to have ranks that are unavailable holding targets, and when those targets are accessed, you'll end up with IO failures. So it depends whether, a lot of the stuff is whether you want the pools to be accessible during what you're doing or not. And in the case that I demonstrated, it saves us one rebuild, right? Because if you were wanting to, if in your scenario, Kevin, you had one rank failing, you wanted to bring it down, or you wanted to fix it, so you repair the DIM, you restart, you rejoin, and then you reintegrate back into the pool. If you didn't have the system level policies, that would take you 2 rebuilds. But if you did have them, you could reduce that to 1. So that was one of the examples that I probably didn't demonstrate very well, but that's what I was trying to demonstrate. Thanks.
Any other questions for Ken, Tom, or Leeway?
Yeah, so incremental rebuild and reintegration will further modify this and make this more seamless in the future. Is that what I heard from Leeway?
Yes, that's right.
Okay, good. And then one just comment. it seems like there's a bunch of complex interactions and some internal state that's managed and maintained. I'm wondering if it would be good for system administrators or consumers of the product to have kind of a flow chart of how these functions interplay and to synopsize all the different dependencies to make them easily consumable. Because I can understand how someone might make a mistake or have a misunderstanding that leads them to do something that we don't want. So just a suggestion. Maybe that's already been conceived, or it's in the Jira ticket, or it's in the documentation already.
Yeah, I think something I didn't explicitly state while I was doing my demo is that there was a bit of an interplay between the self-heal and the interactive rebuild here, right? During Tom's presentation, there was the mention of an eval command, right? After changing the policy. Like if you were to change the policy to restore pool rebuild, you would issue the eval command to then trigger actions. In my case, I didn't change the self-heal policy back, but what I did is I just initiated the pool rebuild start command, right? So there are some potential like interplays where you might be using the two features together in this example. I have some ideas that may be more, maybe more focused on internal developers about getting better visuals, if you will, about how the rebuild, I don't know, for lack of a better term, state machine works, right, under different circumstances, having a clear picture of what it looks like, with the pool map transitions that precipitate a rebuild, what happens when a rebuild successfully completes with the pool map transitions following that, what happens if the rebuild fails, and then may reschedule retries, and what happens if you issue my new stop command that we demonstrated here, like what happens to the state of the pool engines and targets along the way, right? And what does it imply also for the pool query output that one might see at any point in time along this flow. So I can imagine that could be useful to end users, but also useful to me as an internal, engine developer as well.
Yeah, I hesitated to use the word state machine because I'm not sure how it's implemented internally, but that was certainly on my mind. And if there isn't a state machine, perhaps that would be a vehicle to enable much more complex interactions in a predictable way. And then some way to display that the current state of that state machine through a command might give us or give administrators some visibility. But I'd like the idea of a flow chart just to help consumers understand, what to expect. So anyway, just some input. Thank you.
Thanks. Thank you. Yeah.
And I had a question about the rebuild work that's been done in 2.8. So a major issue we have is that when we do a rebuild with 2.6.4 so far, there's massive disruption to user transactions where the cluster basically becomes unresponsive. I was just wondering, have you done any work to make the rebuild less disruptive in 2.8?
So I know we've, like, amongst the presenters here, we've been talking about one of the benefits of allowing exclusion but disabling rebuild, is that we can have a pool query be more responsive. I'm not sure if I can really best answer this question. There have been some folks also doing a lot of rebuild improvements in the meantime, both for 2.6 and 2.8, master branches. Does anyone want to jump in and discuss any other aspects of that?
Sorry, you're asking about the delayed rebuild? I missed a part of the question.
Stability of the system while faults happen and while rebuild is running, right? Being able to, I guess, access state information So
Yeah, I mean the transaction response time just gets incredibly bad during a rebuild.
Mhm. So you wanted to get access to the to the data, or you wanted to know the progress of the rebuild?
Right, we want users to be able to use the system during a rebuild and have reasonable response times.
Ah, I see, I see. So yeah, we are doing some investigation about how to like assign the resource dedicated for rebuild and have better performance throttling on rebuild, because we realized the rebuild might consume too much resource, and when the data set is super large and there are too many data, then rebuild might take a long time, and if it's not it cannot balance the workload, then user might not be able to use data. Yes, this is something we're investigating, but um, it's not like because we do have the framework like um, control the resource based on memory and based on CPU cycles, but based on our current benchmark, it cannot work as intended. So it will be a background activity for us to investigate and improve.
Okay, but so far you haven't made any enhancements in 2.8. You're still working on it.
Yeah, nothing to it, I'm afraid.
Okay.
Mhm.
All right, thank you.
Mhm.
I mean, one aspect of this is, as that Ken showed, is that you can essentially stop all the rebuilds, and then by manually triggering the rebuild commands for individual pools, you can kind of stage things so not everything is running at the same time. That may or may not help, right, depending on how many pools you have and what the workloads on the different pools would be. But that certainly can be a relief while Liang and team are working on the more like automatic, sophisticated way to do resource control.
Yeah, I mean our biggest issue, we have one pool that's just really big, and that one takes like 36 hours to do a rebuild. And during that time, it pretty much the system just becomes unresponsive for the most part. So I guess in that case, it wouldn't help.
Yeah. To improve that, I think there are two directions to go, right? First of all, is improve the rebuild performance, and we did some work into it, and it depends still. The improvement could be significant on some data set, but not all the data set. Depends on the data pattern. So you might or might not benefit from the improvements in 2.8, and the remaining work is really like resource control and other things. So yeah, we'll keep doing some work, and I believe you will see some change in 2.8, but probably not there yet. We'll keep working on that.
Yeah, when you say performance improvement, you mean just the time to do the rebuild, but not the impact to the
Yeah,
cluster. Yeah.
right.
And that's been done in 2.6.5, right? 2.6.5 has those improvements to the performance, so the rebuild takes less time.
Mhm.
I mean, Muhammad said there was like between over a 6x improvement in the time to do the rebuild. Is that correct?
Well, still, I mean, for some data set, yes, but I do believe there is a significant improvement. And if we reduce the time to, well, I know it's not impossible, but if we reduce the time to a very short period, then the performance impact is less important. But the reality is still take hours. Or so,
Still,
yeah, we do.
it's still hours, I
Yeah,
think.
so we do need to. No, I agree. We do need to have better on control on the resource control for the rebuild.
Yeah, I mean, it's not a simple case of simply performance throttling.
Mhm.
I mean, do you have classes of transactions that you can implement so the scheduler can know whether something is a rebuild update versus a user update and take priority with the user update?
Yeah,
So
we do have the framework to control that. But the problem is for rebuild, the data movement is amplified for many for like for EC16 plus 2 is amplified for 16 times for it to reconstruct a piece of data. So that's the problem, and we need to
Yang,
yeah.
I was looking into this code, and so sounds like so we have the scanning and then the data movement. I was wondering whether the scanning is actually total at all, Because the scanning doesn't run on those specific ULTs that are the migrate ULTs, right? If I understand correctly.
Yes, right. So
So
yeah,
I
so we
suspect the
do
scanning is not throttled, and then maybe it is the one killing the CPU. No, I don't know.
scanning and the so for reboot. Yeah, let me dive into the technical details. So for reboot, if you want to reconstruct data on the server, you have to let's put the scan aside because we know scanning is not controlled, but that's one thing. And the second thing is when you reconstruct data, you have to create a URT to grab the data from other servers, right? So the RPC handled by all the server, there is a framework to do the throttle control, but the performance control. But the URT to grab the data, I mean the initiator of the data reconstruction, that URT is not considered as part of the resource control. That's definitely one thing we missed.
I see. So yeah, I think first we should try to make sure everything is throttled, and then eventually make. I mean, I don't know. I mean, I think the metrics we have currently, the 30% of CPU cycle, is probably not a good one too.
Yeah,
Because with 30% of the CPU, you can still kind of kill the network probably
Yeah,
if you do large IO. So that might be another thing to revisit. Yeah.
indeed.
Yeah, and depending on the specifics of the pool that's being rebuilt, there is a status about whether or not the scanning has been completed locally and globally, right? So it may be that for a very long running rebuild, the scanning may be done, but now it's just in the data migration phase. So I'm not sure like which portion of the rebuild is spent, still doing scanning, right? They do overlap a little bit, right? But I'm not sure how long it takes for the scanning piece to complete. If it's a minority of time, then it would be less of a concern, I guess. But we'd have to look at specific examples, I guess, to know whether or not scanning is a concern compared to the migration piece.
I mean, if
Okay.
you are able to make improvements, is that something we could backport into 2.6.5, or we're going to have to wait for a subsequent release to get any kind of improvement?
I think it depends on the improvement, and there's going to be case by case basis. I mean, significant changes will probably only be to 2.8, but we'll
Okay.
see case by case basis on what can be backported.
It
Okay.
cannot be also 2.8 release schedule. So if you have sort of stability period on 2.6, how close is 2.8?
Well, all the fixes will end to 2.6.5, go to 2.8. But you're right, there might be more new stuff in 2.8 that might introduce regression. But others, people from who do testing and CI and the CI can comment. But as far as I understand, we do as much testing on 2.8 that we do on 2.6.5. Is that correct, Sylvia, or Mohammed? I don't know. Who knows?
Cheers.
The 2.6.5 validation plan is the same as the 2.8 validation plan. In terms of validation, we do as much on, I mean, or maybe more on 2.8 than on 2.6.5?
More on 2.8 because
Yeah,
2.8 has new features.